I hate number 16. This is just very difficult to follow. It's kind of confusing. And so the first thing that I notice when I read this question is that there's just like a lot of potential for error. You've got percentages, you've got these two cities that have the same basic name, city X and city Y, two different years, so I've got to keep track of a lot of information. So my gut tells me that this question is really going to come down to whether or not I can show my work in a legible, organized way. Because if I lose something, then the whole question is gone. I need to keep track of everything, and I need to understand this information in the simplest way possible. So here's what I did, is I started off with city X, since that's what we're kind of like focused on. So there's city X in 2010, and there's city X in 2015. I am told that the population of city X was 120,000 in 2010. So literally just like write that. I know it's in a sentence and it's easy to read. Write it out. Get it out there. That way it's more organized. What else do I learn? I'm also told that the population of city X increased by 20%. Okay, so I'm going to use a formula that I introduced on question number 12 in this very test, so that way I can keep track of my percentages. I'm afraid I'm going to make a mistake. So I'm going to use what I call the open formula to keep track of percentages. I made this up. It's in my book. I made it up because percentages are so difficult, we need a formula. And the ones that are out there that are taught clearly aren't working because everyone gets this wrong. So when we're talking about increase and decrease of percentages, what our formula is going to look like is we're going to have the original value, that's the O, times 1 plus or minus P to represent the change in the percentage is equal, that's the E part, to the new value. The original times the percentage equals the new, and we represent the percentage with this plus or minus 1 because it's helpful to see the change. So use this formula, it's helpful. How does that apply to the green here, the value for 2015? Well, we know the original population. It's 120,000, so that's my O. And I'm told that it's an increase of 20%, so that should be 1 plus 0.20, okay? And that's going to equal my new value, which I don't know and I'm trying to find, the value for 2015. So let's simplify this a little bit. So that's 120,000 times 1.2 is equal to the new value. And luckily this is the calculator section, so we should be able to quickly find that the population is 144,000. Awesome. Okay. Now what? Well, now we got to work in city Y. They tell us that the population of city Y decreased by 10%. Okay, so from 2010 to 2015, there was a decrease of 10%. Great. But I don't know what my original value is, so how do I do that decrease? And in fact, they're asking for the original value. So I could guess and check here. But I'm going to continue to use the formula because I want to show you how versatile it can be no matter what kind of percentages situation we're given. They're telling us that in 2015, here we go, this is the important fact, in 2015 the populations of city X and city Y were equal. So now I know that the population of city Y in 2015 was 144,000. Now I've got to take the 10% away from that. But I can't just take 10% of 144,000. That's not how percentages work. They're not reversible. Adding 10%, or subtracting 10% rather, from 2010 is not the same as adding 10% from 2015. So let me show you how this open formula is going to help us here. Okay? We are going to use, we don't know the original. That's this mystery here. That's what 2010 is. So that's my original, and I'm going to leave it as the original in my formula. So that's this. I don't know it. The percentage is a decrease of 10%. So that's going to be 1 minus 0.10, right? 1 minus 10%. To get me the new value, I'm going to smush it in there, 144,000. So why aren't percentages reversible? Well, because the percentage is getting multiplied by the original value. But according to the formula that we just wrote out, we're going to end up dividing by the percentage. As you saw, if you did the other percentages question earlier in this section, if you watched that video, percentages on the SAT are tricky. They often make us divide when we're very much used to multiplying, right? The way we found city X's population is what a percentage is to most of us. That's how we think about percentages. But on the SAT, they twist things up a little bit, and they're often going to make us solve for the original by giving us the result, what happens when we've done our percentage. So we're going to end up dividing. So let's clean up this formula a little bit. So for original, now let's just call it Z, just to keep things with variables. 1 minus 0.10 is 0.90, and 144,000 stays the same. And now what do? We end up dividing both sides by the percentage to get Z by itself. So we need the calculator to do this. 144,000 divided by 0.9, and we get 160,000. So that is our value of Z. That's our result, or our original. It's our result of this equation. It's the original when we do it. And this is what makes it so confusing is when we normally learn percentage formulas, that word result comes in a lot. And I resist using it because so often on the SAT, when we solve for an equation, we think of that as the result. But with percentages, since time and stories kind of affect things, sometimes we're kind of given the result and we're working backwards to find an original value. And so I find that my formula here helps us keep track of all that. If you find a different formula, that's fine, whatever works. But just the key here is show your work. There's a lot of pieces to this question, and it's very easy to lose track of it. There's also a lot of pieces to percentages in general, and it's very easy to lose track of what we're dealing with. So the more we can just kind of put it on the page and be really clear about what we're given and what we're trying to find and where these things go in the formula, the more likely we're going to get it right. But if you had trouble with this question, that's totally understandable. Percentages on the SAT are really, really tricky.